Hey everybody, I am Stefan Seltz Oxmacher, and this is Automated, a Polymath Robotics podcast on automation. Whether that's robots we built before or crazy combos of technologies and settings that someone might automate. I, of course, am Stefan Seltz Oxmacher, CEO and co-founder of Polymath Robotics, and with me is...
And I'm Ilya Barinov. I'm co-founder and CTO here at Polymath, and this is the first time that we're doing this.
Which means it's probably going to be the best.
Absolutely. So let's see how it goes.
To start off, we're going to play a little game, and this is a game inspired by basically how Ilya and I talk to all of my friends and his friends and everyone's friends and your friends who think about building robots, have built robots before. Basically, we're going to take a tech assigned at random from a stack of cards, and we're going to take... What are we going to take, Ilya?
And we're going to take settings. We got little physical cards here, and we'll pick them out and see what we got. So let's start it off. Picking randomly here, we got home use.
And on my tech side, I actually just drew a setting card. The tech side, we have not 3D printed. So basically, we have to come up with a automated company to use robots somehow in homes without 3D printing.
Well, everybody knows, when 3D printers first came out, they were just going to revolutionize everything. Everybody's going to print everything at home. And I kind of fell for that belief early on. I definitely have a 3D printer at home. I use it quite a lot.
I would say that is true. Ilya is actually the only person I know who has ever given me something that they made with their 3D printer. I know it's a knick-knack. Not only does that come from his general Canadian generosity, but frankly, I think there's an underlying need of him as a 3D printer owner to find uses for the 3D printer, which can then coalesce with his generosity and desire to build weird things, and then hands Fibonacci years or whatever.
How else do I justify buying all the rolls of 3D print material to my wife? I have to have some use for it. But in the home use, so what have I seen? If we can't use 3D printing, I think we're probably off to a better start.
I think this is going to be more fun if we do a similar take on where most people would use 3D printing in home use. And I think that's obviously 3D printed homes. And, and how do we build a robot that builds a home without 3D printing? So there's some obvious ideas that now rational, sane ideas might be the types of things that we do for work, which is say automate construction equipment that could build a 3D printer, but that's not really fun. So how about just a humanoid robot to build a house?
Yeah, because if you're gonna lay bricks to make a house, definitely the best way is first build a humanoid.
Yeah.
That works just as well as a human.
Naturally.
And put down bricks. And that's absolutely. Yeah, absolutely. No, there's been a few good startups in this space doing bricklaying, actually depositing bricks, putting down mortar. Mm-hmm. That kind of thing actually I think is much more promising than 3D printing the whole house. Have you ever seen the finishings on these 3D printed houses? Yeah,
I mean, it looks a bit like you're living in a cave.
Yeah. Cave.
I've been to Cappadocia, which is an underground city dug out of sandstone. And that's about the vibe that most 3D printed houses seem to be going for. It's like the Flintstones meet the Jetsons and no one's really happy. Just like when the Flintstones met the Jetsons.
Techno cavemanism. That's something take I wasn't going to see. But yeah, no, definitely deploying bricks and trying to build a house with it. What will be the main problem?
So I mean, I think the business model for something here is in any of the trades, there's a shortage of workers. Basically, I mean, the hype on this is always, hey, people stopped going for trades because everyone went to college, blah, 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 blah. And now I can't find a master mason. So maybe what we're looking at is a robot, probably a shredded robot that can take bricks and lay them out according to a plan. And that therefore replaces someone who's maybe making $45 an hour as a master mason. But I'm not really sure how you would constantly feed a supply of bricks into something like this while still keeping it mobile enough to be an interesting robot.
Yeah, I mean, the scale of the thing is going to be pretty big.
Yeah.
So
which is not going to be hard if it's another big, heavy thing you need to move from house site to house site.
Yeah. It's a thing you got to unload and take time. But at the same time, your pallet of bricks is pretty damn heavy anyway. Mm-hmm. So it's if you could make it roughly the same scale as that. Yeah. Then it could just sit and just grab bricks from a pile itself being within the dimensions and weight class of a pile of freight.
I mean, I think also the problem is from the friends I have who have done stuff in construction and especially home construction, there's not really a great digital model of even where the right? You have like a CAD drawing, an architecture drawing, and then kind of the GC does whatever the GC does, and somehow on the other side you get a house. So I think like the first step is you'd have to take this kind of shaky drawing, turn it into an actual digital plan of saying like bricks should go roughly here, stacked to whatever 10 feet worth of bricks and layers is. And then you also have to move back and forth. I imagine also a rolling robot is going to have trouble as you get beyond the first, 4 feet of bricks. So probably the value add here is you do like the really crappy basic brickwork, the first like 4 feet or so, and you have a master mason in air quotes, or maybe just, someone who comes and adds the next 4 feet of bricks.
Yeah, or you could just have a really tall arm, like a really long.
Because robotic arms are so easy.
Well, absolutely. No, the same stuff that they use for pouring cement at long distances, those really long boomers.
Yep.
Same kind of idea.
If they're totally precise on their own and definitely don't have a person holding like a stick or a rod to control.
Yeah, exactly. No, that'll be it. Well, so maybe we're thinking of homes not the right way, right? You might be thinking of houses, but this kind of stuff, a lot of the construction robotics has come into apartment buildings where you're repeating the same plan over and over. You know exactly where you're putting stuff because everything's been planned out with huge detail.
In fact, one of the guys on our team, Naveen, actually had a had a robotics company where he was framing out commercial real estate. And essentially the bet was, there is kind of a better plan. Let's put some metal rods at 90-degree angles so that people can come in and install sheetrock or whatever afterwards. But the problem again is still the plans. The problem again is when you have a 25-story building, it's really hard to localize, especially if like the broader environment's constantly changing. You start to look a lot like a $800,000 robot to replace someone who makes $150,000.
So you know how you solve this? You need VR for everybody on site.
I mean, the metaverse is obviously the solution.
That's the solution. Why do you need a house if you could just pretend you own a house?
But I think our setting is in home.
Yeah,
and not even construction.
Home use. Maybe we've drifted away from home.
Yes. And this sounds a lot like a robot that you worked on, the Amazon Astro robot.
Well, yeah. I mean, there's definitely some early 3D printed parts in there.
Yeah. Well, no, I just more mean a robot that's driving around that's not using 3D printing.
Yeah. I mean, for sure. Anything you're going to deploy at any kind of scale isn't really going to use any kind of 3D printed parts.
Yeah. Well,
the machine there was really kind of built as an interactive. Some people have described it as Alexa on wheels.
Yeah.
Like an interactive.
I think I have described it as Alexa on wheels.
I mean, everybody does. It's quite funny because at the time, actually, Jeff Bezos put something on Twitter where his kids had taped an Alexa to a Roomba. And this was like halfway through the project. And our team was like, yeah, basically this. Like 5-year-olds have figured out what we're doing better than we figured out what we're doing.
I think the problem of home robots is like it's such a solution in search of a problem. If you want someone to grab you a drink from the fridge, you have children. That's why we procreate, to say, hey, go get me a soda.
That is definitely the next skill I'm teaching my 2-year-old. Why teach her anything else? Yeah, the old like get me a drink from the fridge kind of thing is the ultimate dream of every roboticist.
Yeah, if you took
weird goal.
I mean, like if we're gonna do home use, not 3D printing, it could be exactly what we've talked about in the office before, of taking your old ClearPat Jackal and figuring out how to get it to bring us drinks from the fridge downstairs.
Exactly. Yep. Yeah. No, you know what? Instead of that, how about this? Not 3D printing, right?
Yep.
So 3D printers use a gantry to get around different styles of gantries, but they're moving the hot end around that way. Why not just make the entire interior of your room cable-driven gantry so that the robot right? So you just have wires everywhere. You only need 3 wires. Come on, not that big of a deal. You walk in, there's just a spider web of wires in your room, and this end effector can pop to any position in your space really freaking fast. Like wire end effectors can travel 100 miles an hour, right? So you walk in, it's zoop, right to the fridge, whips it open. There you go. Like if you're going to commit to robots in the home,
your roommate's changing a light bulb, just take it and just so
wipe it's on their feet. Yeah. Why would you not do it this way?
What's also great about this is you could use ML to tag, say, the most thousandly interacted with household devices. You have constant cameras everywhere looking downward in your house to grab anything that you want from any corner of your house at any time.
So you're saying you take Amazon Go, make it less useful and way more intrusive in your house.
Yes, but here's a thing that I often do. Now, I take showers on a regular basis, as I'm proud to admit.
I believe you.
Yeah, when I walk to the shower, I'm in my boxers, take my boxers off, take a shower, leave with a towel. Now, sometimes I forget my boxers in the bathroom. Now, that is unpopular. That is an unpopular thing that I do with the other members of my household, namely my wife. With this gantry system, we could say, go find underwear, grab it, put it in hamper.
I have a better solution.
Okay.
Not a better solution, better use case. So speaking of Amazon, right? The whole idea of the Amazon Go stores is that they use a bunch of camera systems and they figure out what anybody's grabbing. There's no RFID. It's all vision based.
Yep.
You have the same thing to your point. You have cameras and it tracks what you have in your house. And not only does it get you the thing, it knows what you need to buy next. Right? And after the initial phase, after you've gone in people's houses, it starts to accidentally knock over fragile things so that it gets you to buy more of them. Right? Like you only need to do this 2% of the time and your profit margin's awesome. Like that's just
one thing more than that. There's actually been a bunch of SaaS companies who wanted to solve this, like tracking your personal inventory.
Oh yeah, absolutely.
So like, hey, do you have extra AA batteries? If you have cameras everywhere in your house, you'll always know if you have the extra AA batteries, and that you can grab them with a simple, push of an app.
And you know the best part of this whole thing is? If you just have a glue gun sitting somewhere, this gantry can grab that glue gun, and there you have a giant 3D printer. Oh,
so thinking about this as a business, basically what we're doing is we're making it so that at the touch of your fingertips, so you never need to get off the couch, and you can get anything in your home as well as know every item in your home. Now, like, how will we price this out? So you have the cables, you have the nest of cables right through the roof, that's through the ceiling.
High tension steel cables. Yep.
There's probably going to be some complicated bracing for stairs.
Yeah.
And then you need, I mean, honestly, you don't need that good of cameras, just like a cell phone in every corner of your house. Yeah. That's like facing downwards, constantly taking your information to the cloud.
Exactly.
So I mean, if the actual gantry crane itself, maybe that's 50 grand, 25, 50 grand.
You could, depend, how fast do you want this thing to move, right? Do you really want it to whip around at top speed?
So my apartment is 1,400 square feet. So it needs to travel, say, 1,500 square feet within a minute.
Oh, that's slow.
What's that in miles per hour? Freedom units.
It would take you less than a minute to walk across your apartment. So it is slower than walking speed.
Yeah.
So you're talking like a mile an hour, maybe?
That's so bad. All right. So maybe actually this gantry crane can move at, 2 miles an hour.
Yep.
So probably it's only like $5,000-$10,000 or $1,500. Well, it has to be reliable. It has to pick things up. I think it should probably be able to pick up things that weigh up to 25 pounds.
I think we're moving away from my dream of this thing whizzing around so quickly that it's a health hazard.
Okay. Well, I'm just trying to productize it. So it moves at 2 miles an hour. We need, in my apartment, let's call it, 50 cell phones worth of computing cameras.
Yep. That's about right.
So I think, realistically, we need a good name. Something that both encompasses, it's always watching you, and it can constantly grab you. Maybe Panoptograb.
Big Brother Octopus.
Big Brother Octopus, or more Panoptograb, as it's known in some circles. And we think that we can deliver this solution to you in a 1,500 square foot house for the low price of $150,000.
Yeah.
And you can sign up for our Kickstarter today and be able to grab anything or anyone in your home.
Not including the insurance required. So let's move into some personal history time.
Yep.
I've heard you've had some previous experience with autonomous vehicles. Just a little bit?
Yeah.
And of course, when you started your previous company, Starsky, you knew exactly the direction to go in.
Yep.
Yeah. All right. Well, let's tell the real story. So how did that start off?
Of course. Yeah. So as background, Polymath is my second robotics company. My first one was a company called Starsky Robotics. We, at peak, raised $26 million. We're about 100 people. We were a self-driving trucking company. So we did everything from operate a trucking business all the way through install sensors on trucks. And we completed what, to my knowledge, is the first unmanned trip on a public highway in the world. And if that is surprising to you, it's because in general, the narrative around autonomy is, it's basically here and blah, 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 blah. when in reality, very few people have ever driven a vehicle on a public road without a person in it.
So you started off knowing that autonomy was difficult then?
No, I did not. Basically, I was a SaaS sales guy who had like worked around some startups and done some things more interesting than just being a SaaS sales guy. But I went on a road trip with a Craigslist roommate who had turned our desk in our living room into a robotics lab. And we had like a 5-hour drive with nothing much to talk about. So we started talking about what his next robotics project should be. And I was like, oh, hey, what if we made trucks into drones? What if we made trucks remote control? You know, if Northrop Grumman can have guys in Reno fly drones in Afghanistan, how hard could it be to have like people in Reno drive trucks in Arkansas? That seems like it must be easy and it's valuable because of driver shortages.
So how hard can it be is one of those famous robotics lines. It gets so many people in trouble. On another note, though, of roommates building labs in the home, I guess robotics lab is the least harmful, or maybe most harmful version of that, depending on your perspective.
Really destroyed that IKEA desk.
So I guess, at least it's just the desk.
That's true.
Yeah. So how hard could it be? Well, what happened?
It turns out quite, and like and not even for like the fun reasons. Like when people hear that initial idea, they think like, yeah, well, sure. What about latency? And like, how are you going to solve that? And that like sounds like it should be the gotcha question, but actually just like making a thing remote control is pretty hard.
In what sense?
So I don't know if you know this about self-driving trucks. You need a truck to make one self-driving. You need to install motors on it. You need someone to drive this truck that happens to not be a public road. None of those are things that I had when I started working at this company. Like when we first had money, we had like 150 grand. A truck costs 150 grand. So it's like, are we going to have no money and just buy a truck? Like that was hard for a while because I had this like really crappy, like 15-year-old stick shift car. Every time we wanted to test, like even just our mechatronic device, it was like, let's get around, install some actuators on it in a non-destructive way. Find a sleazy parking lot that's mostly used by drug dealers and love-lost teenagers and try to drive in circles without hitting anything too hard. Like every part of it was actually really hard, even before the fun stuff to talk about like latency and like regulation and insurance and whatever.
Yeah. And you mentioned before that there's a problem with standardization on these vehicles. How did that show itself in your roadmap?
Yeah. So, Ilya, do you know, for example, the angle that the accelerator is at in a Freightliner, let's call it 2017 Freightliner Cascadia, just between fronts, the angle of the accelerator is at and the distance of that accelerator from the floor?
I do not.
Yep. Neither does Freightliner.
I feel like they should.
One would think, but like in reality, they make something like 10 million Priuses a year, which works out to something like a Prius is built every like 5 to 15 seconds. They make 50,000 Freightliner Cascadias a year, which is a lot less frequent than once every 15 seconds. And as a result, it's just like this like Lego block jumbotron of crap just jammed together. And essentially, trucks are made at such lower volumes, and as a result, they're all way more different than cars are. And in the early days, that was troubling with things like, where exactly do you put the actuator for the accelerator? And in later days, it was hard because we would literally have a subject trucking company that we could take trucks out of, and we couldn't guarantee that 2 trucks we took out of it that we leased for the purpose of this would actually be very similar for tuning, say, our longitudinal controller. Tuning so that when we push the accelerator a little bit, so that we could go from 62 to 65 miles an hour, it would instead put us to 70 miles an hour, which might happen if it wasn't tuned the right way.
Well, but Stefan, I'm an engineering genius. I'm just going to machine learn this problem.
Yeah, I mean, that would be great. I still don't really understand why you can't. Like, in terms of like controls, one would think machine learning could just be this magical solution that could change it all. And I've definitely argued at 2 autonomy companies that I work at, one of which I'm currently at, and I've been told time and time again that no, you should just hire controls engineers. And do you know what controls engineering is, listener? My guess is, unless you have a robotics degree, you have no idea what I'm talking about. This is a made-up discipline. Controls engineering, that's not real. There's mechanical, there's software, there's civil, and sure, maybe there's some stuff with electronics. Controls, not a real discipline.
Yeah, I mean, basically, Stefan has cracked the secret of controls engineering, where actually controls engineers just connect remotely and just twiddle the wheels manually, and that's how all the controls work. We just ship a little man in a box with every system that we ship.
Ilya, maybe you can explain to the listener what controls engineering is and what it actually, why is it so hard?
Well, I'm going to steal one of your talking points because I think it's one of the better ones I've heard. So you get into a shower and you turn on the hot water, and like it gets too hot, so you make it colder. It gets too cold, you make it hotter. And you're basically trying to control the temperature. So you do this kind of wiggle back and forth. Controls engineering is that, but doing that via software and doing it as efficiently as possible. The ideal case is, you know, your system, your plant so well, you have such a good model that you can predict that if you just set the knob in your shower to this value, you're going to get exactly the right temperature, which I keep hoping I'm going to do at home, but I never see what to do. But it's basically that. It's taking an input, having a model of your plant or your system, and controlling the output of it so it does what you want. For robots, it's steering, it's throttle. Those are the main things you're trying to control. But there's a bunch of secondary things like how quickly do you want to accelerate? How quickly do you want your acceleration to change?
Why is that so important? How quickly do you accelerate?
Well, slamming on the brakes is basically deceleration, and doing that randomly without controllers would be pretty bad.
It's uncomfortable for the rider.
Yep. Yeah, it's the change of velocity is called acceleration. The change of acceleration is called jerk. And you will feel like a jerk when you're sitting in one of these vehicles. And it makes slams on the brakes with no warning.
I would also call out for the aspiring autonomous vehicle founder, controls engineers is somewhat like hunting for Quetzalcoatlus or, I don't know, Florida jaguars or albatrosses or dodos or some animal that is so rarely seen that we could argue is mythological. Basically, nobody studies to be a controls engineer anymore. 90% of the controls engineers I've ever met were like from some country where they thought, oh, cool, I'll have a great job if I learn how to run the power plant. And controls engineering is a great skill set for running a power plant because, hey, if you start pumping up too much power, you have a meltdown. If you have too little, people can't watch Netflix. And both of those are problematic. So
different kind of meltdown.
Yeah, very different kind of meltdown, but nonetheless severe. So as a robotics and autonomy founder, I found myself needing to hire for this role and this skill set that frankly I didn't really understand and couldn't really find anyone who did, because before the autonomy boom of 2016, 2017, there was like 15 controls engineers in the Bay Area. Maybe that number is 150, but I think I once had a recruiter show me a report in like 2020 that said there was in the realm of 1,500 controls engineers in a market that literally has 50,000 software engineers.
Yeah, that sounds about right. And a bigger scope, what makes robotics really, really complex is that you need those specialists in controls, and you also need the specialists in machine vision, and you also need the specialists in kind of software quality and deployment and those things to actually make a product.
But can they just use machine learning for the controls?
Yeah, I will see it one day.
So why isn't that true?
Using machine learning for controls is kind of, it's using an atomic weapon to kill a fly. Like you
kill the fly.
Yeah, you also take out like several city blocks around yourself.
I didn't like anyone who lived in that city.
Yeah, it's overkill in the extreme, and that you're running a very black box system to what, but hopefully by definition, maybe one of the things about controls is you really want predictability. You want to be able to predict in your, across your range of inputs, here's how the plant is going to work. Here's your output's going to work, especially for mission critical, safety critical stuff, power plants, healthcare systems,
steering on the highway. It's steering
on the highway. Exactly. And a lot of what controls will do is they'll do this kind of linear analysis where they'll say, given my entire range of inputs, what does my output look like? And they'll test the extremes, extreme minimum, extreme maximum, the middle. In machine learning, it's very difficult, and there doesn't seem to be a good understanding right now of proving that given a set of inputs, your machine learning algorithm will do the same output every time. Right.
And couldn't you just say, have a unit test that said your steering angle output is now 45 degrees and we're driving on the highway at 65 miles an hour? Don't do that.
Absolutely. And you will prove that for that set of inputs, your outputs are predictable. But what about if your outputs are slightly different? Right. The problem with the machine learning is that there's no good understanding of what the neural network is doing at any given time. And so it's very hard to fully prove across all possible sets.
Ilya, how big is a neural network? Just so that those of us who did study robotics might have an understanding of what's going on.
How big is a neural network?
Yeah. Couldn't you just like draw it out on a whiteboard?
Oh, yeah.
Status?
It scales with the complexity of your inputs.
Yep.
So the most common ones for image recognition and those kind of things, you're talking about a few thousand input nodes, a few tens of thousands of hidden layer nodes, and a few dozen output nodes, that kind of size. There's more modern techniques that kind of abstract away from particular node sizes, but you're still talking about tens of thousands of variables for anything that's not completely straightforward.
Yeah.
And so maybe you could scale down your control problem to the point where your machine learning system is trying to predict one or two variables. But at that point, a classical controller is going to perform as well, if not better. You haven't done anything, right? Like speed control via machine learning seems to be overkill, whereas machine learning for control of very complex systems seems very risky because you don't know what's going to happen. So I don't really like at the low end or at the high end, I don't see a good reason for this approach. This will be one of those moments where like 64K is good enough for everyone's forever. I'll probably be proven wrong, probably be proven wrong in the next few decades, but I haven't seen a good approach for it.
Yeah. So in terms of other things that are hard, sorry, robotics company. So a thing that was persistently hard early on is, I don't know if you know, Ilya, many truck drivers or many people, trucking executives.
Unfortunately not.
Yeah, that's a bummer. They turn out, like many people, to not have a great understanding of what is easy or hard in robotics. So I found myself often in this place where I talked to a trucking company. They're like, yep, this is fantastic. Give us all the automated trucks you can make. Fantastic. Do you guys know how to use them? No, not really. Okay, cool. Do you guys, for example, have all of your information about where you should drive on a road by road basis? Does that exist somewhere? No, not really. When we rate things, we say drive from Atlanta to New York. Like, okay, well that I'm just putting things into Google Maps, and that's pretty hard. And then they'd say things like, well, yeah, why don't you do this route? You'll pick up this load in San Antonio. You'll then hop on the highway, drive for a while, get to Dallas, and then this last part's really fun. You're going to take this exit that isn't really an exit. It's not really marked. It's about 3/4 of the way between this exit and this exit. You're going to follow that road for about a mile, turn left at the church, drive on a dirt road up a hill. And that road, sometimes it washes out, so it moves around a little bit. And then once you get up there, you're going to go into this dusty area where you have to pull up and then open up a lever on the bottom of your trailer. You guys can automate opening of that lever, right? And we'd be asked stuff like that I would then, go to the engineering team and be like, hey guys, can we do this? How hard, Ilya, could that possibly be?
No, not difficult at all. I mean, to solve the trucking problem at that point, you have to invent artificial general intelligence. And in the hierarchy of needs of artificial general intelligence, driving a truck is low down that scale.
Even things like, for example, that moving that lever on the bottom of the trailer to dump out the materials. Another version of that question I'd be asked, I actually had someone on my team who was like, yeah, I mean, we can swap out trailers all the time. Just have the engineers throw together a little arm that unplugs the pigtails, unplugs the air brake lines, and we're good to go. Why is that so hard?
Humans are incredibly dexterous.
What?
We don't. I
thought we were lazy and worthless.
We don't admire this enough about ourselves, but our human hands and our perception ability are second to none in the animal kingdom, much less the machine kingdom. Even things like picking up a ball and manipulating it with your fingertips or throwing it up and down and catching it is cutting edge, if not impossible, in the robotics world. And trying to do arbitrary manipulation. So not only do you have to move this handle on this truck model, but it could be any handle on any truck model. It could be painted different colors. It could be stained with oil. It could be jammed at a certain point because it seems to be a little bit sticky.
But I can figure that out. Why?
Yeah, humans are great at it. You have this great processing node sitting on your shoulder and you have really, really accurate manipulation. You know, if you look, there's products out there, there's a shadow hand that tries to reproduce human manipulation. Costs, right, I mean, I'm going to lie about the exact number, but multiple tens of thousands of dollars. And it's a fraction of as good as a human hand is.
Yeah.
So you're talking, to get something even close, you're talking about hundreds of thousands of dollars, at which point you've blown your cost budget out of the water for a guy who has to come over and flip a lever.
Yep.
So that's one option. The other option, of course.
What I ended up finding, and like what our product decisions were at Starsky, was, all right, so these trucking companies, they don't really know how to use robots because frankly, a self-driving truck is a more complicated product than an airplane, and trucking companies on average, not always, but on average are less technologically sophisticated than airlines. So what we ended up deciding to do was essentially we'd be the trucking company so that the need of the robotics could be less. So we could just say, these are always going to be our trailers. Hopefully we don't have to add anything to the trailers, but we can if we really need to. We're only going to drive to these special whitelisted routes that like we already know are really, really good. And the problem is that business really sucks for investors because not only do we have all the capital requirements of a trucking company, we have the margin of a maybe good trucking company. And then it actually almost sped up the problem of what is safety and how do you make this problem safe?
So as an investor, though, why do I care about those things? Like, why would I care about that for?
So I used to really not understand it. And like at the end of Starsky, I like really dug into, you know, hey, I could make with, you know, a total of $100 or $200 million of investment, we could be $100 billion a year company that makes a 50% margin. And that's, you know, that's so much better than needing 10 times the money and making $1 billion a year with a 90% margin, I thought. Another thought that I had that scared the bejesus out of me is that if I ever like mentally broke, if the stress of like dealing with angry truck drivers and weird, you know, state legislators and engineers who like got their feelings hurt and engineers who like said stuff that offended those other three groups, if I ever broke, it felt like the company would shut down. And I realized that's not how SaaS works. And that's why investors really like SaaS. Because basically, half the people in San Francisco can run $1 billion SaaS company. It's a very easy skill set. Like you show up, you talk to some people sometimes and you're not a jerk. And like, you know, you can like say some stuff about how XYZ widget for B2B SaaS is going to change the world and democratize electronic signatures. It's like a way easier thing than like, hey, I'm going to single-handedly operate a trucking business that employs tens of thousands of people while building cutting-edge technology no one else in the world knows or cares about.
Yeah, I mean, that sounds like a harder problem.
Yeah.
It definitely. Yeah, especially for engineers who get into engineering for the people skills. That's the main reason we go into that.
Yeah.
So tell me about safety in Starsky.
So an interesting thing at Starsky was essentially we like could plausibly take the person out of the vehicle very quickly. The first time that we did something that looked like that was, I want to say like September or October of 2017. We drove 60 miles with a loaded trailer where the human who was sitting behind the wheel didn't need to do anything from beginning to end of the trip. Like,
nice.
If that person had not been in the truck, we would not have killed anybody. We would have driven. Like, that could have been a driverless truck. It is then kind of terrifying to realize there's no clear playbook for taking the person out. And that was weird.
Well, what about ISO 26262 that everybody talks about?
It's a hell of a standard, but like even like going lower level than that, like when you're in school, you get a rubric at the beginning of the semester that says, here's what the tests are going to be that are worth this much towards your grade. Here's what the homework's going to be. It's going to be worth this much towards your grade. Here's how you get a good grade in the class. And then I would promptly ignore all that. And you would think like when it came to taking a human out of an 80,000 pound vehicle, driving 55 miles an hour, 2 feet away from your mother, you would think there'd be a similar rubric. And you'd think like the smart people would have a rubric, but it basically turned out that didn't exist. And I'd like go and I'd talk to like safety people. And I realized that most safety people are working off of a rubric made for the particular industry that they work in, be it automotive or aviation. And that if you can't like fit that spreadsheet, they're like, I don't know, might not be safe. Or I don't know, it's outside my pay grade. Like basically we were operating where there wasn't a rubric, where there wasn't a scorecard outside of like, don't kill anyone, please. And that's kind of terrifying. That's like kind of intellectually terrifying. Realizing not only you're the adult in the room, but maybe you're the adult in the world.
Kind of makes me think of the original when cars got on the road.
Yeah.
There was no seatbelt laws. There's no even driver's license early on. There's barely a windshield.
Yep.
It's just you felt like you could drive and you would start to drive, and that was it.
And the world was great then.
Yeah. Plenty of safety on their system.
It actually reminds me more of my favorite story, which is how the aviation industry got regulated, which is the Wright brothers pretended to be the first airplane in like 1906. The Red Baron shot down some people in World War I. And then suddenly people were like doing airmail and whatever the 20s. But all these bozos would go up in the air and like play ping pong on the wings of an airplane at 5,000 feet and like do stunts and jump from one plane to another just to show how cool they were. And what ended up happening is like the nascent serious aviation industry, like literally like Hunter Douglas or like Boeing, whatever his first name was, like Jeff Boeing, Jim Boeing, was lobbied together to create the FAA to stop bozos from doing the equivalent of like falling asleep behind the wheel of their Tesla. This is how aviation regulation happened, because like they realized that if this was an unsafe industry because of idiotic barnstormers, they would never become billionaires. And that didn't fly with them.
So my comment on that is, if you're going to send your Wright brothers hate mail, please send it to Stefan. I want no part of this.
I think I just started a fight with the whole state of North Carolina.
I am completely neutral on that state.
As a Yankee, it wouldn't be the first time.
Yeah.
So essentially, we kind of got scared by this. And I realized, talking to other people in industry, that others were similarly scared. Like there was like whole teams that would be able to hand wave away unmanned deployment by saying, oh, the machine learning and the edge cases, and probably it's a state senator's fault. In our case, you couldn't say any of that. And like, you just had to be like, all right, here's how we're going to make this drive no person. And the problem with that, outside of the fact that there's no real agreed upon standard, there's no real agreed upon rubric, is like there's this combination of what is morally acceptable to deploy, what is engineering smart to deploy, how do you like manage the PR of deploying something, and those all like kind of sound like safety but are all kind of different. So what we ended up deciding is like, all right, we want to be really safe, we want to hold ourselves to a standard that maybe no one else could even understand. On the engineering side, the most nasty and terrible thing about safety is that if you're serious about safety, you're going to hurt some numerator over some denominator of people, and that numerator is greater than zero. Like if you think your system can never hurt anybody, you're not doing engineering, you're living in a fantasy fairyland, and that's cute, and you can go back to kindergarten. But if you actually want to deploy a safety critical system, you have to say, all right, one time out of some number of times, we're going to kill someone's child or mother or father or uncle or best friend or soulmate. One time out of some number.
Hopefully billions.
Hopefully billions, but maybe it's tens of thousands. Maybe it's thousands in certain applications. So what we decided from an engineering perspective, because it's the most measured number, is that our goal would be greater than whatever the human number is. Because a lot of people study what the human number is. There's a lot of data. There's a lot of justification of the human number is this, the human number is that. Cool, we have a data set. We'll say greater than. If the human number is 1 out of 1,000,000 miles, we'll say 1 out of 1,000,001 miles or greater, because we can incredibly measure around it. And then from a PR perspective, I learned that that's a whole other thing altogether. Fun lines that people would love to say is like, oh, well, the first time one of these that hurt somebody, the whole industry is going to shut down, your company is going to fail, which isn't really true. Like safety PR ends up being its whole own weird thing that somehow actually incentivizes hurting more people than less. I had a conversation with, maybe I shouldn't say who exactly, but some people who ran safety for a very prominent app that's on your phone. And the first time people on that app accidentally killed somebody in an accident, it was a whole big deal. The CEO flew out, they paid for the funeral, they gave the family $200,000. It was front page news for 3 months. The second time it was 1 month worth of news. The third time it was a week's worth of news. And now that company, in accidents that are justifiable, kills somebody every single day and you don't notice it. And you still use that app. In reality, the nasty thing about safety PR is the best number of people to hurt is 0. The second best number is greater than 350. And that's terrifying. That completely conflicts with that moral and ethical idea of let's build a thing that is safe and makes the world better as opposed to worse, which greater than 350 is worse.
But Stefan, I have low disengagements per mile on my autonomous vehicle.
Oh my gosh. So I lived through this and this was the worst. For a while working on Starsky, the premier metric of measuring an autonomous vehicle was disengagements per mile. Basically, if you are driving your self-driving car from Best Buy to Target, how many times in that trip does the human safety driver need to turn off the autonomous system to make sure that doesn't get into an accident? And you, the listener who has not read 18 blog posts about the subject, could be forgiven for thinking that makes sense. That makes a lot of sense because obviously the lower disengagements per mile, the better the thing. Now, it's really, really hard to measure other people's robots. Really, I mean, like
it's hard to measure your own robots.
Yes, but other people's robots, especially if you are, say, a poli-sci major who now works in the state government of California, it's really hard to measure somebody else's robots, especially when the industry doesn't have standards about safety, let alone like what is a disengagement per mile? Because does it count as a mile if the system's fully on but goes into shadow mode if there's a failure? Is a mile on the highway the same as a mile in a city? All these things take a number into a number with a couple of paragraphs attached, which doesn't work. But my favorite of all of this was that at Starsky, summer of, I want to say 2017, we had the disengagements per mile up on the dashboard, and it started going up. And it went from like 12, 15 to 75 miles per disengagement inside of a month. Like, holy shit, guys. We figured out the machine learning. It has solved. We had built an autonomous truck. We're going to be billionaires next week. This is awesome. So my co-founder flew out, spent a week in the truck with the test driver, and realized why the miles were going up so much. Because essentially our test driver knew that we cared about this metric, knew that we were telling her, great job. The test you just did, I don't know if you know this, there's only 2 disengagements in your 150-mile trip. And what she was doing was basically, as long as there was no one around the truck that she was driving, she would never turn that system off. So, you just veered through a lane. Let's keep it rolling, boys. There's someone coming up. Maybe I'll just like nudge the steering wheel to the right because there's no torque disengagement sensor so that we don't bump into them if something bad happens. And boom, we had great disengagements per mile. I've heard of top tier robo-taxi companies do stuff like if the vehicle is driving and the safety driver gets uncomfortable, they push a button where the vehicle keeps on driving in shadow mode. The safety driver does all the driving. Then when it's no longer in a sensitive position, they turn off shadow mode and they get credit for all of shadow mode when the vehicle didn't get to an accident as against its disengagements per mile. Which, like, sure, kind of, but it's just a bad metric. Like, a better metric, frankly, is like trips in a row without a person needed. And that's essentially like what we used at Starsky for when we took the person out of the vehicle. We did something like 150 trips in a row without needing a disengagement from beginning to end. And that gave us a reasonable amount of statistical certainty that on the 151st or the 152nd trip, we could go from end to end without needing a person and we'd be safe.
Yeah, it's interesting because it seems like the industry has centered on this disengagements per mile, and Google and those folks will talk about that quite a bit. Do you think that's kind of more of a policy problem, or is it more of a PR problem, or how did we get here?
Yeah, I mean, I think the problem is essentially that it's a nice, simple number that can mask a lot of complicated stuff.
People love simple numbers.
Yeah, when you think about like what a metric really means, is it's a number to capture a broader sense of how things are going without needing much more context. So disengagements per mile ends up looking like a really great metric and people have kind of locked into. And frankly, we all thought we'd have self-driving cars by now. So as a result, the legislators, the regulators, they locked in a bunch of things that they thought would be relevant in 2015 into state law. And that's not because they're dumb. That's because like they believed the hype that everyone else believed. They saw like 15 articles a week coming out of reputable newspapers saying, look how close autonomous vehicles are. They thought, hey, I guess autonomous vehicles are close. Maybe we should address this issue. It's probably going to matter.
We should install a new segment next year about bets on how far away level 5 autonomy is for on road.
There's a guy named Steven Schlaudover, Dr. Steven Schlaudover, who's I'm pretty sure, I hope that's his name, who's been a researcher into autonomous vehicles for like 40 or 50 years. And I had a coffee meeting with him once a couple of years ago. And at the end of it, I said like, hey man, this must be really cool for you. You've been working on this field your entire career. Must be pretty exciting to see it finally happen. And he like scoffed me off in like a very like grumpy old man type of way. And basically said, the thing I've learned about this industry is the more you learn about it, the further off you think it is. And given that we're saying this in a week where a $1 billion company just wound down, I think that's absolutely the case, which is why now we're not working on on-road autonomous vehicles.
Yeah. Argo AI shut down, and the dream of on-road autonomy seems to be getting a little bit further. What are we working on, Stefan?
Yep. So essentially what we're working on, a weird thing that happened while working on Starsky, is we would constantly have big, weird companies reach out to us and say, hey, do you drive a truck on a highway? Could you automate our turf cutter that we sell to sod farms all across the world? And we'd say, not really, because in robotics, you have to build every single part of the stack. You're not just building the autonomy, you're also building the hardware layer, you're also building the business logic that tells that autonomy what to do. And in our case at Starsky, you're also the trucking company. So pivoting all of that to be sod cutting robots or yard trucks or hauling shale, whatever, would actually be essentially a whole pivot. What we're doing at Polymath is we're building a generalized autonomy layer for industrial vehicles that a technical team can apply to any vehicle large enough that it should come to a stop when it gets into trouble. And the reason for that is that kind of essentially mobility unlocks robotics in much the same way as operating systems unlocked computers. You know, before there were common operating systems like Windows or even early Mac OS, to make anything on a computer, you needed like an army of IBM people to design some awful data center thing with punch cards, build all the like operating system for it, and build some awful primitive application to like multiply numbers so that you can figure out where boats were and stupid stuff like that nobody cares about. With operating systems, you made it so that people could just build the program, and that program could tell you where a boat was, or it could tell you how much money you lost this quarter with your boat navigation software company. And it could go on to do stuff like give you internet access, and then the whole world that we know have happened. In the same way, when people try to automate industrial vehicles, all of them spend the first 2 to 4 years of their life getting able to drive from point A to point B without hitting anything. We're building that so that the teams who care about specific applications can focus on the specific apps for those applications. Whether that app is till this field, whether that app is push this dirt in this quarry, whether that app is pull this trailer around my farm. And that's why, listener, you should immediately go to Polymath Robotics and sign up to build all of your stuff on top of it. So that whether you're as stupid as me or as smart as Ilya, when you build your thing, it can actually, do something neat sometime soon.
Straight out of the 1920s radio book.
So, Ilya, thank you so much for interviewing me today.
Inquisition mode.
For the next episode, the turntables will turn, as some say, and I'll be peppering Ilya with questions about robots that he's built in the past, and hopefully sound smarter than I might have sounded today. But in general, this is automated. We're going to just talk about building robots. I've talked not necessarily about which algorithm where, but what are the weird hard product problems that you find? What are the weird problems when you have to pitch the thing that you can actually build versus the thing that investors care about? What are the weird problems that you think will be really, really easy? How hard can it possibly be? and end up being the part of the product you fight against for the next 5 years?
The answer in robotics is always it's harder than you think.
Always.
In every situation.
Regardless how many PhDs or how many of your team went to CMU, it's always going to be harder.
Or Waterloo.
Yeah. You can find us at polymathrobotics.com. I'm sure we'll have some subpage that says our podcast, but for now, you'll just have to search a little bit harder, which I believe in your ability to do. So next week, I'll be interviewing Ilya about his experiences at companies like ClearPath and Amazon's Astro program. In the future, we'll have some friends on who are hopefully just as crass and open as we are. And if not, we'll kick them off. And no matter what, we'll certainly be running through more of these cards, because the next one that I just drew is a walking robot. Ilya, what's the setting that you... Walking robots for delivery is what we have next. So will it be Spot? Will it be C-3PO? Will it be a Mecha Warrior? We'll find out soon. Please join us again. Feel free to subscribe. I promise I won't send you too many crappy emails.
And we look forward to your Wright Brothers hate mail. Talk to you soon.